7 pieces of rope have an average arithmetic mean, okay, length of 68 centimeters. So the average of 7 ropes is 68 centimeters, so the sum of the length is going to be 68 into 7. This is what will go through my mind as I read this sentence. And a median length of 84 centimeters. The median length is, so the middle value is 84. Okay, so let's try to visualize this. So there are 7 elements and we are given that the middle element is 84. So now this is in the increasing order, ascending order. If the length of the longest piece of rope is 14 centimeters more than 4 times the length of the shortest piece of rope. Okay, so we are given a relationship between the longest piece of rope and the shortest piece of rope. So let's take the shortest piece to be x, and then in that case this is going to be 4x plus 14. Right? So now the question is, what is the maximum possible length in centimeters of the longest piece of rope? So we have to find what is the maximum possible length of this. So we have to maximize this. In a maximization question, the main question is what are the constraints, because if I don't have any constraints, this could be infinite, right? The maximum value could be infinite. It's going to be limited only by the constraints that are given. So are we given any constraints? Yes, so we are given one constraint is that the sum of these 7 lengths is going to be equal to this. So even if all the remaining 6 lengths are 0, the length of the longest rope cannot be greater than this, right? So that is the maximum value of the longest rope that is possible if all the remaining ropes are 0 in length. But can the remaining 6 ropes be of 0 length? No, that's not possible, because we are already given that the median is 84, right? So at least one rope is of length 84, and we also know that the smallest rope is of length x, and if x is 0, then of course it will also determine the value of the longest rope. So we have a bunch of constraints here, but we still want to minimize the lengths of the 6 ropes. Why? Because the sum is fixed. So if I want to maximize the length of the longest rope, then all the remaining ropes I have to minimize the length. So the length of this is given to us x, and the length of the middle rope is also given to us as 84. Now what about this rope? Can it be of 0 length? No, right? I've already defined this to be in increasing order, right? So the minimum value of this has to be x, because the previous element is x. Similarly, the minimum value of this third element is also going to be x. And then we have 84. Then we get to this element. What is the minimum possible value of this element? It has to be at least 84, right? And again, for this also it's going to be 84. So now we have the values for the lengths of each of the ropes. Now we can just add them up and equate them to 68 into 7. So what we'll get is 7x plus 14 plus 3 into 84 is equals to 68 into 7. Solving this, I'll get x to be equal to, so 74, 94, 76 minus 252 minus 14 by 7. So I get 210 by 7, which is 30. So I get x equals to 30, and so the length of the longest piece of rope is 4 into 30 plus 14, which is 134. So that is the answer. So the thought process makes sense. The important thing is the thought process, because only if you understand the thought process can you solve a similar problem in the future. If you have any questions, please feel free to ask.